A very good morning to all of you. So today we will be starting with psycho-visual redundancy. If you remember, while discussing redundancies, we discussed coding redundancy and interpixel redundancy. And today we will start with psycho-visual redundancy. Normally, this redundancy is relatively of less importance as compared to other redundancy. So, if we define psycho-visual redundancy as human eye does not respond with equal sensitivity to all visual information, certain information simply has less relative importance than other information in normal visual processing. This information is said to be psycho-visual redundant. It can be eliminated without significantly impairing the quality of image perception. So, this is fact about an human eye that a human eye does not respond with equal sensitivity to all the visual information. It always depend. It will always respond to very good sensitivity to a particular visual information, and it might not respond to any non-good sensitivity with the same visual information. This kind of information can be removed from the image. Why? Because ultimately when we are looking at the image, if that is not making much impact in the image appearance, then we can remove such type of information, and that kind of information is called psycho-visual redundant information. And how do we eliminate this kind of information? Its elimination is possible only if information is not essential for normal visual processing. We say that information is not sensitive and your eye is not sensitive and sensitive to your eye. So we can eliminate this kind of information from the image. Since the elimination of psychovisual redundant data results in loss of quantitative information. So here you see psychovisual redundancy. If we are removing psychovisual redundancy, that means we are removing quantitative information from the image. And this removing quantitative information is referred as quantization. And this process or this process in whole is called as quantization, and this whole process of quantization is irreversible process. It is irreversible process. Therefore, the quantitative we use in lossy compression. That means some of the information is lost in the quantization. So it is irreversible since the information lost during the quantization cannot be retrieved back. Hope this is clear. Since the process since so it is irreversible, since the information lost during the quantization cannot be retrieved back. So if we cannot retrieve back, now let's see how can we reduce the psychovisual redundancy. Here we have three images. You can see this is the original image we have. So this image is represented by 8 bits, means total 256 gray levels are used to represent this image. Now the same image is represented by 4 bits, means 16 number of gray levels. As we know from the first unit, if we reduce the number of bits to represent the image, then we start noticing false contouring in the image. The false contouring is being noticed, so this is visible in the image also. So what we do here is, when we start watching false contouring, we use IGS quantization. What do we mean by IGS quantization? IGS is improved grayscale quantization to remove the false contouring. Doing this from 8 bits to 4 bits, we have achieved 2% of compression ratio in IGS quantization. We are we have reduced from 8 bits to 4 bits, and we have achieved 2% of compression ratio in IGS quantization. Also, the compression ratio will be 2 only when, why? Because we will still have 4 bits to represent each pixel. This means total 16 gray levels. But how do we convert this image to IGS code? We can see here IGS code. For that, we have a method. Initially, suppose that these are the gray levels of the pixel which we want to convert into the IGS code. Then what is done? The initial, for the first pixel, the gray levels are taken, and the process is that first we convert gray level into sum. You can see here we have the gray level, we convert into sum, and from that sum we find the IGS code. So for the first pixels, all the gray levels are taken as the sum. This is taken as the sum, and MSB 4 bits are taken as IGS code. This is taken as IGS code. So for next grade level, this is our grade level. How will we find the sum? We add four lower significant bits of previous pixel and this pixel. Okay. So 0 plus 1, 1, 0 plus 1, 1, 1 plus 0, 1, and 1 plus 1 is 1 plus 1 is 0. And here, and one carry will be added here. One carry will be added here, so that will be 1, and this will be as it is, and this will be as it is. So this will be as it is. So if carry is added, then that will be added, and if not generated, it will remain as it is. Then from this only higher MSB is taken into the IGS code. Then in the next, again you see, this is 1 plus 1, 0, 1 plus 1, again 1, and 1 carry, which is written there, carried over there. Again we have 0 plus 0 equals to 0, 0 plus 0 equals to 0. So the carry will be written there. So the MSB is as it is. Then again here same way the MSB will be taken as IGS code, and in the case when the higher side is 111, the higher side is 111, nothing is added, the same value is taken as IGS code. Then these four bits of IGS code, then these four bits of IGS code is used to represent this image. So in IGS code we are using 4 bits only, but the false contouring is not appearing in the IGS code representation. In IGS quantization we are not sharing the false contouring which was appearing in the 16 level representation of this image. This is how we can remove the psychovisual redundancy. Hope this is clear to all. Thank you. Thank you for listening me so carefully. Stay home, stay safe. Thank you.